This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, well, I'm going to start. Obviously, it's quite a beautiful day outside, so I'm assuming 90% of the people decided to just enjoy the sun today rather than coming here. They're lost. Anyway, so clearly, I'm not Eduardo. So let me start by introducing myself. My name is Maria, and Eduardo probably told you at the beginning of the semester that I was co-teaching this subject with him. So he was responsible for delivering the first half of the course, and now I will be taking over until the end of the semester. Now, I know that I have really, really big shoes to fill, because I think Eduardo is an amazing lecturer. He's really, really passionate about teaching. He's really passionate about helping you guys, about this course in particular. But I promise you that I will be doing my absolute best to try and keep up the amazing work that I think he's been doing. Obviously, keep an open mind. We're different people. We have different teaching styles. Like, you know, plain slides here, no fancy colors or anything like that. But we have something in common, and that is that we're easygoing, approachable people. We're here for you. We want to provide you with the best learning experience that we can. So, you know, feel free to approach me with any questions, any concerns, constructive criticism, more than welcome. I'm here learning as well, so let's help each other out, all right? Any questions before I start? Is this usually the amount of people that come to a lecture? Is it? All right. Oh, yeah, deliverable today, so this week, all right. Okay, well, so today we're talking about concurrency. And this is a favorite topic of mine. Maybe that's because I work with distributed systems in my research. So concurrency, you know, I pretty much deal with it on a day-to-day basis. But I think most developers do not share this passion with me. And I think that concurrency is massively, massively overlooked in the industry. There are various reasons for that, but mainly I think it's because it's really, really hard. It's hard to think of, it's hard to test, it's hard to program for, it's hard to reproduce bugs that are due to concurrency. So I think maybe people think if they ignore it, it will go away. But I can guarantee you that in today's distributed systems era, there is no hiding from concurrency, right? Like, you will have to face this once you go out into the industry and start implementing these amazing enterprise applications. And if you're not dealing with it, I can tell you now that you're doing something terribly, terribly wrong, and it's going to come back to bite you. So take advantage of these couple of lectures, pay attention. I know that it will be really, really useful for you guys in the future. So, and if you have any questions throughout the lecture, feel free to ask. No issues. Okay, so here I am, like, throwing the same concurrency around, assuming that we all know what it means. And we probably have a pretty good understanding of the definition of this word, but I will go ahead and define it anyway, because I want us to, one, be on the same page, and two, have this concept clear in our minds. So for those of you who are really, really familiar with this concept, you probably learned it in another subject. Just bear with me for a moment. I will first talk about concurrency using a real-world example, and then I will define it in terms of enterprise applications, okay? So we all use roads, right? And we always share these roads with hundreds of other people. We use them at the same time. And some of these roads, you know, intersect with each other. And what this means is that we have a bunch of cars that are potentially going to be traveling through shared portions of roads at the same time. We put it in other words, we have a bunch of cars that are concurrently traveling through intersections. All right? Now, if we have no control, or we have no access control into these shared portions of roads or intersections, then we're going to have accidents happening. And this is where concurrency control comes into play. So concurrency control, in this particular example, would be traffic lights or stop signs, right? We use these mechanisms to synchronize access to the shared resources so that we can avoid different types of issues. So in programming, we can think of concurrency in a very similar way. We say that two actions or two events or two computations are concurrent if they happen at the same time and they happen or they are acting on a shared set of resources. And the key here is shared resources, because if these actions were happening at the same time but on a set of independent resources, then we would say that they are parallel, and then none of the issues that we're discussing here today would apply. Yeah? So keep that in mind. There is a difference between parallelism and concurrency. Think of parallel roads as opposed to intersecting ones. Yeah? So you can see that this is a very broad definition, very general, so it applies to many different systems at many different levels. Anyone can give me an example in concurrency, applications that you use daily, devices that you use daily? Anyone can think of any example? Think about the operating systems on your laptops. Like, do they have to deal with concurrency in any way? Anyone wants to say how? An example? Because there's many different perspectives you can take, but just anyone would do. No? So for example, we have multiple, I bet all of you have multiple applications open, running at the same time. And so all those applications are sharing a CPU, are sharing memory, they're sharing network interfaces. So that's one type of, concurrency that we can think of. Any other examples, something else that we use daily, that we'll heavily rely on? Internet. Yeah. An example of concurrency in the internet. Anyone? No? We don't like participating? Anything would do, whatever. I know that you're thinking of it, it's fine. No? All right, well, internet, what comes to mind is network links, network resources, and we are sharing them with millions of other people at the same time. Another perspective to concurrency. Anyway, you can see, you get the idea. Concurrency is everywhere, many different levels, many different perspectives. So the perspective that we are going to take in this course is we're going to study concurrency issues that arise because multiple users are trying to access the same data at the same time. All right? This will be our focus. In this course, we're sort of taking for granted the fact that enterprise applications can support multiple simultaneous users, right? So in your workshops or in your projects, you're implementing web applications that somehow, we're not really concerned with that, how allow multiple users to use your applications at the same time. But even though we're not concerned with the how, I want us to look a little bit at behind the scenes today and understand how applications are supporting this, because it will help us understand why concurrency is going to be an issue and how concurrency can cause issues, yeah? So, anyone has any idea how a server or an enterprise application is supporting multiple users? What technique is it using? Most likely. There's different ways, but there's one that is widely used. Anyone? I'm sure you have all heard this word before. Anyone knows how Tomcat in particular, the web container that you're using, supports multiple requests to the same server or servlet at the same time? No? Yes? Yeah, threads, exactly. So it's multi-threading, basically, the answer. So we have multiple threads running, and that's the way that we can allow multiple users to use our applications at the same time. Anyone happens to know exactly how Tomcat do it? How does it use multi-threading? Do we know a little bit more detail? So Tomcat actually uses a model called a thread per request. So every request that is sent from the client to the server, a new thread is spawned to serve that request. Yeah. So the request or the thread is actually going to execute whatever instructions you have in your do post or you do get methods. So if you think of it in an enterprise application like the ones that we're doing in this course, you can have multiple instances of your do post or do get methods running at the same time. And you're probably starting to think at the moment how that may cause some issues. All right, so we know it's multi-threading, but anyone knows how the operating system handles multiple threads, sharing a single CPU?
Between the different threads.
Yes.
In a shop times.
Exactly. Sorry?
Round robin.
Yeah, it could be round robin, it can be anything, but the key is that the operating system uses a sort of time-sharing mechanism, so it allows each thread to use the CPU for a tiny fraction of time, right? And during that tiny fraction of time, the thread is able to execute a subset of its instructions. And then it moves on to the next thread, and then comes back to the first one until all of them finish executing, yeah? The thing with this model is that as developers, we can make no assumptions whatsoever about the order in which the threads will execute or the order in which their operations are going to execute. And so there is an inherent indeterminism to this that is really going to make our life difficult as developers. But let me show you, that's okay, a quick example, a quick demo here, so that this is clear for everyone. That's probably, I'll see how we go. But anyway, I have a little demo here. I have a printing. Can you see? How do I make this bigger? Wait. Is that better? Can everyone see that? So I have a little toy program here. I have a thread, a Java thread. It's called a printing thread. And all it does is a loop from 1 to 3, and then it prints the thread name followed by numbers 1, 2, and 3. Yeah? Simple, straightforward. And I have a little single-threaded printer program here. Everything, all that it's doing, it's creating a thread called thread A, and then it starts that thread. So at the moment that we start the thread, the for loop is going to run. Yeah? So if I run this, oh, this is so annoying. Anyway, the output, can everyone see the output, although it's little there? Yeah, 1, 2, 3. Right, nothing unexpected. But now here I have a multi-threaded version of my printer. So what I'm doing is I am creating 3 threads, A, B, and C, and then I am starting those threads in that particular order, yeah? A first, then B, then C. Anyone wants to have a guess at what the output of this program will be? Anyone? So you think thread A, 1, 2, 3, B, 1, 2, 3, C, 1, 2, 3? Is that right? Anyone else? Random? Okay. Anyone else? All right. So, well, let's have a look and see what this will print. Oh, yes. It didn't happen that way. Anyone expecting this output? Well, the one that said you used it random, so probably you were expecting this. Well, you know, something random. But that is exactly what happened. It's random because we cannot make any assumptions whatsoever in how the operations will interleave. All that we know is that the thread is going to start and it's going to finish. That's pretty much everything that we can say. So if I run it here again, we'll probably get a different output. See? There's absolutely no logic to that from our perspective. And so probably here even thread B started first, even though we started thread A first. So it's completely random. So you can see now here if our run method instead of a loop was our do post or do get methods, we can see how operations that we have in those methods can interleave in a way that are going to cause a lot of consistency issues in our applications. All right. So let's have a look at a high-level example that is probably going to be more relevant and more similar to what we were going to be dealing with. Imagine that we are implementing a banking application. So we're going to implement this bank transfer function. We're going to transfer from account A to account B, X amount of money. So what would be the first thing that we have to do logically? Like if we're writing the pseudocode for this function, what is the first thing that you do? If you were tasked with implementing this function, what is the first instruction that you would have in that function? We're going to transfer from A to B. So, anyone? Yeah, but let's go higher level than that. We have to declare variables and then logically, like at a really high level, what is the first thing that we do? Yeah, basically, that's what we're going to be, but let's go a little lower level. We take the money from A and put it in B, but do we have to make any checks? Yeah? What do we have to check?
Balance of A is greater than the amount we want to take.
Exactly. We have to make sure that A has enough funds to transfer the money. So this is one way of implementing it. Of course, it could be done different, but we first go ahead and retrieve the balance of A. Then we check, make sure that that balance is greater than the amount that is being transferred. Then we update the balance of A by deducting the amount that is being transferred. Then we get the balance of B, and then we update the balance of B by adding the amount that is being transferred, right? Simple, like really straightforward. This is a really quick working example. I'm not going to spend much time on it. I just want to test if this method of using this pen would work, because you can't see the board on the lecture capture, right? On the videos. Has anyone? Yeah, so I'll try it. I'll see if this works, and then we take it from there. So we want to transfer from Alice to Bob $40. Alice initially has $50. Bob has nothing. So we retrieve Alice's balance. It's 50. We check that it is greater than 40, which it is, so we can go ahead and execute the update. We update Alice's account, so now she has $10. And then we retrieve Bob's balance, update Bob's balance by adding the $40 to him. So now at the end we end up with a database that has these values in it, right? Easy. Now let's have a look at what would happen if we had two concurrent transfers in our system. Yeah. So we have, it's going to be the same transfer just for simplicity, but it doesn't necessarily have to be this way. First, we get the blue transfer. So from Alice to Bob, $40. Same, get Alice's balance. Make sure that it is greater than whatever money she's transferring. It is greater than 40. So we were going to go ahead and update Alice's account, but before we could do that, we got another transaction into the system. So this thread got suspended, and the operating system decided it was time to give CPU time to this new transaction. And so this new transaction comes in, retrieves Alice's balance, which is still $50, checks that 50 is greater than 40, it is still greater than 40. We update Alice's account by deducting the $40 from her, so now she has $10. We get Bob's balance, still 0. We update Bob's balance, we add the $40 to Bob, and then Bob has $40. Up to there, all good, right? No inconsistent state. But as soon as this transaction finishes, the CPU resumes the one that it suspended. So now it's time to update Alice's balance from the blue transaction, yeah? If you recall here, this is where we left off, and this check was successful, so we go ahead and update Alice's account. And this is the balance that we had in memory, because this is what we read here, which is 50, $40 that we're transferring, so we're updating Alice's account to $10. That doesn't make a lot of sense, right? She still has $10 even though she's transferring another $40. And then we update Bob's account. We retrieve Bob's balance from the database. At this point, it is 40. We update it with an extra $40. So now lucky Bob has $80. Yeah? You see how that should have never happened. This transaction should have never been allowed to execute. Yeah? So this is the sort of issues that we're going to try to prevent when we are implementing our enterprise applications. Now, you may think that this is a highly fabricated example just to scare you, you know, like concurrency is bad, but everyone knows about Bitcoin. Yeah. In 2014, there was this Bitcoin bank called Flexcoin, and it got hacked and it got robbed of all of its Bitcoins. It was around about 14,000 US dollars, and it had to shut down because of it. When the company went and did a post-mortem to try and realize what had happened, they realized that the attacker successfully exploited a flaw in the code which allows transfers between Flexcoin users. By sending thousands of simultaneous requests, the attacker was able to move coins from one user account to another before the balances were updated. Exactly the example that we just saw. It's how this poor company was robbed, right? This is why I think that concurrency is massively overlooked in the industry. You probably have thousands of products like this out there. Actually, there's a paper called Acid Rain, and they test 12 e-commerce applications, open source e-commerce applications, and then only one of them actually passed all the concurrency tests. And then this poor Polynex company, probably written by the same developers that wrote the Flexcoin application, got hacked in the same way. So this just highlights the importance, right, of considering these type of issues. Any questions so far? No? All good? All right. I'm going to try to speed up a little bit. So we know that concurrency causes issues, but let's define a couple of them that are really relevant for us. The first one is called lost updates, the exact example that we already saw with the transfers. This problem happens when we have two transactions that are updating the same data item. So the operations interleave in such a way that one transaction reads the data before the other transaction has had a chance to update it. Quick example, you can go through these examples, you know, on your own time. It should be easy enough, but here we have two transactions to make a deposit. One is depositing $10, the other one is depositing $1,000. So blue transaction first, we get Alice's balance, it's $50. Before we get to update the account, we get another transaction to deposit $1,000. We get Alice's balance, we update the balance by adding the $1,000. Alice has $1,050. When this finishes, then the blue transaction resumes. It updates Alice's account, but because it had read 50 before, it's going to use that to update the new value of the account. So 50 plus 10, it's 60. It updates the database and it overrides this update that the other transaction made. Yeah? Any questions? Okay. The other type of concurrency problem that we're going to see is called an inconsistent read. This problem happens when we have one transaction that is calculating a sort of a summary function over multiple data items, and we have another transaction that is updating those data items. So the transaction that is estimating the summary may read some values before they are updated and some values after they are updated. And so this is going to lead to an inconsistent value. Quick example, we have a new transaction here. It's called net position. Oh, all it does is it adds the balances of different accounts. So in this case, we have Alice with a loan account. She owes $100. Alice's savings account, she has $10. So her net position is minus 90. Okay? So that's the first transaction to come in. We get the balance from the savings account. At this point, we get a transfer function like the one we saw before. We want to transfer $5 from the savings account to the loan account. So at the end, we end up with these values in the database, yeah? 5 from here to here. We go ahead and retrieve Alice's loan balance at this point, which is minus 95, because we already put $5 in it. And we estimate the net position using 10 which we read before it was updated, and 95, which we read after it was updated. So now we have a net position of minus 85, which was never true. It was never, Alice's net position was never minus 85. It was always minus 90. Yeah? Any questions? Okay. And then finally we have deadlocks, but to explain deadlocks I need to talk about logs and pessimistic concurrency control first. So I will come back to these once we have the background to understand it, all right? We have 5 minutes left. Okay. All right, so it is clear now that we need some sort of concurrency control. And this means that we need to manage concurrent transactions to preserve the integrity of the data. And so far in the course, and in particular today, I have been throwing the term transaction around as if it was just any other term. But transactions are the primary tool used by enterprise applications to handle concurrency. So it's a key term. It's really important that we understand the definition. You probably heard this term before, Eduardo, maybe when you were talking about unit of work, identity map, the word transaction was thrown around. So it's pretty important in enterprise applications. We can define a transaction as a sequence of write and read operations that are indivisible. So all of the operations execute successfully, or all of them are rolled back. Yeah, there are no changes at all to the data. Probably heard this term before in other subjects. You've heard about the ACID properties. Yeah. So that's how transactions help us maintain the integrity of the data. Let's quickly go through them, just because it's on the slides. But atomicity, all the operations execute or none of them execute, or I mean the changes are not persisted. Yeah. Consistency, if a transaction starts and the data is in a consistent state, then when that transaction finishes, the data must still be in a consistent state. We have isolation. If a transaction is updating data, then no other transaction can see that data until that data is committed by the first transaction. And then finally, we have durability. Transaction results are permanent. Yeah? So the context in which I'm assuming that you have heard a lot about transactions is databases. Yeah? And this is what we will be referring in this course as system transactions. Yeah? Generally speaking, a system transaction is simply a transaction that is supported by the underlying transactional resource that we're using in our enterprise application. Transactional resource is simply a system that uses transactions to handle concurrency, which in our case is almost always going to be a database management system. So for simplicity, we think of system transactions as database transactions. Yeah? What is a database transaction? Anyone? A set of SQL statements. Yeah? So this shouldn't be new to you. I know there is a lot of definitions and background before we actually get to the patterns in this particular topic. So it's maybe a little bit different to what you're used with, Eduardo, but we will get to the patterns. I just think that this background is going to be really important so that you can apply those patterns correctly. Because the patterns on their own, there are only 3 and they're really simple. It's just all of this background information is key to this topic. So I think we're going to leave it there today, and then we will finish on Tuesday next week. Are there any questions about this or the project or anything urgent? Because the deliverable is this Sunday, so remember that Eduardo made an announcement reminding you of the key things that you have to have on your submission. Please don't forget anything, because you will lose marks, and it's a silly mark loss there. So, all right. Okay, well, we'll leave it there, and then we'll finish, because otherwise we're sort of left in an in-between topic that is just going to be confusing. So we'll just stop there today. Okay, thank you. If you have any questions, come and talk to me. Sorry?
Just I have a question about component diagram.
Yeah.
I wasn't exactly sure like what are we supposed to put. Is it like the layers and everything inside each of the layers, or like what are we supposed to put in a component diagram?
In a component diagram, you're supposed to show the. I don't want to give you the answer because I feel like you should know this from previous subjects. Yeah, have you? If not.
I know sequence diagram, I know class diagram, I think I know domain diagram, but I'm not really sure that we can component diagram.
Alright, so in a component diagram, you're meant to show the different components of the application and how they interact and communicate with each other, like using different interfaces. So, for example, perhaps the workshop example with the workshop, you have your presentation layer.
Yeah.
You have your presentation layer, you have your domain layer, and then you have your data source layer, and then you have your database.
Yes.
Each of those can be seen as a different component.
Okay.
Yeah? And then the presentation layer interacts with the domain layer somehow. So maybe with a component diagram, there's a way of specifying interfaces. Have you seen that and how they communicate with each other?
Interfaces as in, for example, like
It's very simple because it's very high level. I just realized that this the lecture finishes at 3:15, doesn't it?
Yeah.
I thought it was 3. All right. Let me see if I can have maybe I'll show you here. Guys, I just realized that I finished the lecture really early. I'm sorry. I thought it was until 3, but it's at 3:15. So use this time for your project or whatever, or questions. So you have.
I think there's something.
Oh, here. You have a component, and then that component. Let me make it easier for us. This one. Component. So, you have a component,
Yeah.
you have an artifact, you have interfaces. Frames they don't really matter. You have, and then basically you have dependencies. Yeah, this deployment part doesn't really matter to us. So a component. Let me see if I can get not interface component. Right. So component can usually it depends on your project, but it can be either a single class or a package.
Is it like too big?
Yeah, it depends. It's all logical. So in this case, let's say you have your presentation layer and then your domain layer.
Yeah.
They are logically like different components of the applications because in theory you could deploy them on different nodes,
Yes.
right?
Yeah.
So they're different components, but you can organize these components however you want. It's up to you. You can organize them like layers, or they can be packages. Like how are you organizing the packages in your application? So packages are grouping classes in a sort of logical way because those classes belong together for a reason.
Yeah.
So usually your packages correspond to
Particular layer.
a component or a layer. Yeah.
Yeah.
classes in there. Yeah. And then one of these classes, perhaps is the one that is exposing an interface that is going to be accessed by someone on another component. Yeah. And so it looks like something like that. Yeah. So it shows you how things are logically components and how they're going to interact with each other. So this could be. I'm not saying it's say too much, but you see.
I think
yeah.
I'm
And then in the data source there as well, and then the database can be represented as an artifact or another component. It doesn't really matter.
Is the database itself a part of? Isn't the database a part of the data source layer as well? Or is it like, data source layer is like a layer to interact with the
I see it more that way. I think we're talking about it more that way in the course.
Okay. So
How we interact with the database. So if you have layer, and then you have the database here, and then